Okay, so dA. How about dA? Now to get to the equation. So you know A is equals to U minus TS, right? The definition of A. Okay. So dA is going to equals to du minus TdS minus SDT. Okay, and you put your du inside here, so TdS will cancel out. Okay, so you end up with dA is minus SDT plus minus SDT minus PdV. Okay, so that's another equations. Okay, and this equation also tells you partial A, partial T at constant V is going to equal to negative S. Okay, partial A, partial V at constant T is equal to negative P. Okay, and the very last one is actually your dG is equals to negative SDT plus VdP. Okay, so you can just say G is equals to U minus TS. Okay, and then dG is actually dH minus dTS. Okay, and basically these two terms. Okay, and you put the dH in, and you got this equation. Okay, so here you will see, okay, I'll just write out partial A, partial T at constant V is equal to negative S. Partial A, partial V at constant T is equal to negative P. Partial G, partial T at constant P is equal to negative S. Partial G, partial P at constant T is equals to V. Okay? So these four equations are very important because it tells you the temperature and pressure dependence of your free energy. Okay? What this says is actually the temperature dependence of free energy under constant pressure is going to equals to your entropy. Okay, so this term is actually the temperature dependence of your free energy under constant pressure is related to your entropy. This is the pressure dependence of free energy under constant T is related to the volume. Okay, we'll come to this part in the end of this lecture or early next lecture. Okay, but for your midterm, all the content in your midterm, okay, will cover the content to this lecture only. Whatever I say in the next week, it won't appear in your midterm. Okay? Alright, so there are 1, 2, 3, 4, and 5, 6, 7, 8, 12 equations here already, right? You are going to have like 20 equations to remember. But in the end, it's all coming from this form. So this is important. This is extremely important, okay? These four equations, once you can write it out, you can remember all those 20 equations. Okay? So where are the other 8 equations? Okay, those 8 equations will be the so-called the Maxwell equation. Okay, so in your next hangout, you can see I just write down the Maxwell equation over there. Okay. So let's start from here. Okay. I'm going to erase this. Okay, so we now know actually U, H, A, and G, they are all state function, right? When it is a state function, that means they are exact. Okay, anyone remember what exact means? If A is a function of B and C, okay, then BA can be written as partial A, partial B, a constant C, dB, plus partial A, partial C, a constant B, dC. Okay, if A is a function of BC, then BA can be written as this. Okay, if A is exact, that means then partial A squared, partial B, partial C should equals to partial A, partial C, partial B. Okay, once you fulfill this one, we call the A is an exact function. Okay, and it's very straightforward. You just do the differential in different orders, but you're actually doing exactly the same thing. Okay, therefore here you will know the T is actually your partial A, partial B now. Okay, so you know partial T, partial V, a constant S is going to equals to negative partial P, partial S, a constant V. Okay? So basically this guy, you do a derivative against your dV, okay, under constant S. It's going to equal to that guy, you do a derivative against S under constant V. Okay, so this is the first equation of your Maxwell equation. Okay, using the idea of exact differential. Okay. So here for your dH, you can also write. Okay, this is your right. Partial T, partial P, a constant S, is going to equals to partial V, partial S, a constant P. Okay? Here you will write negative partial S, partial V, a constant T, is going to equals to negative partial P, partial T, a constant V. Okay, of course, negative will cancel out to end up with this. Okay, and the very bottom one will be negative partial S, partial P, a constant T is going to equals to partial V, partial T, a constant P. So there are another 4 equations to remember. Okay? And the very last 4 is actually, you can flip this over. So you're going to have partial V, partial T, a constant S equals to negative partial S, partial P, a constant V. Partial P, partial T, a constant S equals to partial S, partial V, a constant P. Partial V, partial S, a constant T equals to partial T, partial P, a constant V. Partial P, partial S, a constant T, don't forget the negative sign, equals to partial T, partial V, a constant P. So these are the 20 equations. A lot. But it's okay, right? You know, if you know how it comes out, all you need to remember is just 4 equations. All right? So, actually, for these equations, okay, especially for the Maxwell equations, it's actually very easy to remember. Okay, assuming today I give you, let's say, partial t, partial v, a constant s. Okay, write down what will E equals to. If you look at this equation very carefully, okay, it's always st, pv, pv, st, st, pv, pv, st. Okay, so there's a relationship here. So st, pv, pv, st, st, pv, pv, st. Okay? So if today I give you this, okay, partial t, partial v, a constant s, then you should immediately know, okay, because st is a pair, pv is a pair. Okay? So you should be able to write out this immediately. Okay? And then the next thing you need to know is actually looking for the t or p. Okay? If you have t, s, okay, on the top you should have p, v. Okay? This is how you remember it. It's actually very easy to remember. Okay? So assuming, there's one more thing. One last thing is actually the sign. Because some of them actually have a negative sign in the front. Okay? So how do you make a judgment? Okay, consider this. If you have an ideal gas, if you have higher temperature, you're going to have larger volume. Right? So this one is positive. If you have larger pressure, do you have larger entropy or small entropy? Small entropy, right? If you have larger volume, you have larger entropy, but P is inverse proportional to the V. Okay, so if you have larger pressure, you're going to have small entropy, so this is negative. Therefore, you need to put a negative sign in the front. Alright? So this is how you remember the Maxwell equations. Okay, so if you know how this equation was generated, all you need to remember is actually 4 equations, right? These 4 equations. Okay. And the student will ask me, what if I cannot even remember those 4? What should I do? That's okay. So, how do you remember these 4 equations? And all these 20 equations, okay? The thing you need to do is actually draw a box. Okay? And you draw 2 arrows. Okay? So you can see on the side, you have these 4 state functions. Okay? This means actually the U is a function of S and V. H is a function of S and P. G is a function of P and T. A is a function of V and T. Okay? So once you have this, then you can write, okay, notice we have 2 arrows here, right? What it means is actually, once you see the arrow, it's negative sign. Okay? So you will know the U, Okay, let's focus on the u for now. Okay, u is going to equals to s. So there's no arrow, so it's positive. Okay, s dt minus v dp. Oh, sorry. U is equals to positive T ds minus P dv. Okay? So this go back to here. Okay, for the edge, you have ds and dp, right? And it's all positive sign. So the edge is actually T ds plus V dp, which is this guy. Okay? G. Okay, G will express as dp and dt. Okay? So G is going to equals to V dp negative T ds. So negative S dt. I always get confused here. G is equals to V dp minus S dt. Okay? And the A will be negative S dt minus P dv. Okay, so using a figures, you can get those four equations. Everybody gets it? Okay. Let me say again, because this is crucial. You need this table for sure. Okay? So first you need to recognize the four state function. Okay? U, H, G, and A. Okay? It's always on the side of this square. Okay? And this guy will be expressed as a function of S and V. That means U is something ds plus something dv. Okay? So if you see, so U is going to okay, so once you see this, you should write down this. Alright, that's step number one. Okay. Number two, you know, see these cross lines? Okay, that's the things it's going to fill in this blankets. Okay, so for the ds, then you have t, so it must be t ds, and the v will be P, okay, P dv, negative, so that's the second step, okay. Third step, you need to make sure you put the correct sign in front of it, okay. For the ds term is positive, for the dv term is negative. That means here should be negative sign. Clear? And you can do exactly the same thing for the other four, then you can generate these four equations. Okay? So now you know how to generate these four equations. Okay, how about the other 16? This table also tells you all those. Okay, use this table, you can actually get all those informations. Okay? So previously we say the partial t, partial v, a constant s is going to equals to negative partial p, partial s, a constant v. Okay, so let's use this as example. Okay, s v t s, s, I'm sorry, t v t s, t v t s. Okay, so what you do now is actually is draw a line. Okay, and you look at sideways. Okay, so partial t, partial v, partial p, partial s. Everybody sees that?
Or should I draw this? Maybe I should draw the. Yeah. Partial t, partial v equals to partial p, partial s. Okay? What's the sign? Look at the arrows. If the arrows are on the different sides, you should put a negative sign. Okay? That's how you get to this. Okay?